So I'm Lakshmi Bairavasundaram. I work at VMware. This is work that I work with my co-authors as an intern at NetApp. And this was the 2007 summer, and then the work was published at FAST 2008. So thanks to Garth, Bianca, Andrea, and Remzi for working on this with me, and it was a blast working on the paper. So just a few thoughts on the work. Pre-2007, there was very little data on disk failures. So my personal sort of like journey on disk failures started when I was working with like Vijay and Andrea Remzi on the Iron file systems work. And Andrea and Remzi had sort of like painstakingly assembled the evidence for all of these like non-fail stop failures, like latent sector errors and data corruption. The only issue was that a lot of the evidence was either in the form of anecdotes or the sample sizes in the studies were a little bit smaller, on the smaller side. So there was a lack of like large-scale data on disk failures in general, and especially for these non-fail stop ones. 2007, 2008 was a great time for a lot of those studies to come out. So there were studies on complete disk failures, and as well as the work that we were doing on both latent sector errors and data corruption. So the latent sector errors one was published at Sigmatrix, and our data corruption study was published at FAST. So a little bit about the study itself. The study covered around 1.5 million disk drives, and the amazing part was there were more than 400,000 instances of data corruption. So it was detected in the form of checksum mismatches in NetApp storage systems. And what some of the highlights of what we found were that what we call nearline disk drives developed these mismatches an order of magnitude more often than enterprise disks. And it's very relevant because nearline disk drives are the ones that are in wide use today, even in enterprise storage systems. We also found that these data corruption events showed both significant spatial and temporal locality. The main big takeaway that spurred further work was along the lines of what I mentioned around nearline disks. What we found was that in a 17-month period since each drive was shipped and deployed, these disks, around 0.66% of them developed some form of data corruption. If you notice, that's in the graph, the x-axis is disk age, the y-axis is the fraction of drives that have that develop checksum mismatches, and the one circled in red is basically the nearline drives weighted average line. What was even more sort of like shocking was that there were disk models that had a substantially higher percentage of them develop these data corruption scenarios. So that was one of concern, and that we believe that, along with some of the other studies that I mentioned, spurred further work in the data corruption handling space. In terms of impact and relevance of the work, I looked it up on Google Scholar, and there were around 376 citations. It's pretty interesting that they sort of like stayed consistent and steady over time. It's remained a topic of interest and concern for the entire sort of duration. And in terms of industry relevance, industry has now widely adopted various techniques to protect against these sorts of disk drive failures. So we have things like two-drive failure protection. That's very common today. It was not as common at that time when NetApp had like the row diagonal parity paper, for example. Checksums are widely used in pretty much every enterprise storage system. And there's referential integrity checks to make sure that things don't get written to the wrong place on the disk drive, essentially. And there's also like periodic disk scrubbing that's going on that's validating it. So it's not necessarily because of this one paper, but that sort of like set of papers and that set of like knowledge that was generated at that time allowed the industry to move to better data protection techniques. And of course, like since the paper was published, SSDs have become very prevalent, widely used. The interesting thing is these sorts of like drive errors are very relevant in SSDs as well. A lot of work cited there, like folks have looked into data to see that yes, they do happen with SSDs too. And data corruption remains an active area of research. Just the other day, I saw an RFP from Meta on silent data corruptions and looking for work along those lines. So I'd really like to thank NetApp for the opportunity to look at the data and publish about it. So it's pretty amazing. Like they had the foresight to include detailed telemetry in their products well before like it was commonplace. It sort of takes your product from a product to a service, and that's an important transition from the customer standpoint. So many other companies have like embraced that with Gusto and like have made it like center stage from their customer standpoint, and that is an interesting trend as well. The NetApp leadership at the time had the vision and the courage to publish about it. Like these are enterprise systems. It's not easy to like go like publish data on them, and it's pretty amazing. And again, I see that many companies have seen that like leadership like be very useful to them. Like that there are more companies willing to publish data now, and that's another sort of like exciting trend. Also, the people at NetApp, I'd really like to thank everybody that was there that helped us with the study, helped us understand like how data was generated, how it was processed, and for us to be able to like do the analysis. And again, thanks to all of my fellow authors, Garth, Bianca, Andrea, and Remzi. It was a blast working with them. Thank you.